Hi everyone, welcome to our video on finding area using definite integrals. So with area, we have to be careful with this type of vocabulary. Area considers all regions as positive, all positive. Whereas net area has above the x-axis is positive, but below, so above x-axis is positive, but below is negative. Okay, and the net area itself can just be set up using just one integral. So one integral, let's set it up like this. That would equal the net area. So you just need one integral for that. Whereas regular old area, we might need more than just one integral, so it depends on the picture. Okay, and we'll always get a picture, which is something we could do in a graphing calculator, or if we're fine with plotting it, we could do that too. But we must see the parts that lie above the x-axis and below the x-axis, and often it's necessary to find those x-intercepts. And then from here, we'll use definite integrals or geometry, like if it's triangles, or like trapezoids or circles, we could use those formulas too. Okay, but let's take a look at these scenarios. So it says use the definite integral to find the area between the x-axis and f of x over the indicated interval. Okay, so that's our a and b kinda. Okay, so or first x, second x, however way you want to think of it. Okay, and with this 5x minus 8, I'm gonna plot that just real quick using the y-intercept. So we have the y-intercept would be down 8. Okay, so that's 0, negative 8. And then the slope is 5, so that would be up 5 over 1. So it's something, let me try that again. So it's not going to be super accurate with my up 5 over 1. I'm just going to draw something that is up 5 over 1, we'll pretend, like that. And this is where, all right, so now let me just go ahead and use our graphing calculator. All right, here we go. Oh, that's too big. Okay, so here's that. So let's just get 5x minus 8 plotted real quick. And that way we can see the intercept. So it's 1.6. Okay, so that 1.6 is important. So 1.6 comma 0 is where it crosses. So let's label that too. Okay, so that's our picture, and what we have is, well, let's label. Let me keep it in black color. So 1 to 6. Okay, so 1 we'll pretend is about there. So it's definitely before 1.6, and then 6 is somewhere over here. So this is not to scale, but what we have, let me do this in red. The red area would be considered as a negative. The blue area we're going to consider as a positive. Okay, and so the way that we want to break this down, so regular old area, we need to make sure that they are both considered as positives. Well, since the red would usually be considered negative, we want to just put absolute values around it. Okay, so it starts at 1 and it goes to 1.6. So that's going to be our first interval. So from 1 to 1.6, that's the part that's below the x-axis. So we'll set that up as, so I'll keep it in red, so 1 to 1.6, and then it is the same. This is our function 5x minus 8 that we would use in our integral. So 5x minus 8 goes in, and then we just attach dx at the end to show that's the variable that we're doing the integral with respect to. But now, again, this in the red is considered, would be a negative number, so we just make it with an absolute value around it. So at the end of it all, we'll just make sure it stays positive. And then we'll add, so plus, this area in the blue is automatically positive, and it starts at 1.6. 1.6, so I'm going to do double highlight, and it ends at that 6 there. I just didn't mark it on our picture, so the x is 6 where it ends. So this one goes from 1.6 to 6, and then it's still the same function, 5x minus 8. We just put that in parentheses, and then we put dx at the end. Now this one I don't need absolute values because it should be positive no matter what. And then now let's just go through it, and we'll take our time. Okay, so we need to do our integral. Okay, so we'll keep this. Let's go equals, and I'll put big absolute values there. I'm going to keep my colors. So 5x the integral of 5x would be 5/2 x squared, and then minus 8x. And then from here, I could still do my vertical bar, 1.6 up top and 1 down below. And then we have plus, well, here's what's kind of nice. It is the same integral. So it is 5/2 x squared minus 8x. And then but what changes is the 1.6 to 6. Okay, so that's how we want to break that down. And then now, just keep going with it. All right, so we would want to plug in. So hopefully that's enough room where I want to plug in the 1.6. So I'll do it in black this time into that x. So we have 5/2 times 1.6 squared minus 8 times 1.6. And then again, let's put that in parentheses. And then it's always minus. Let's do it in green. Always minus the second one going in. So minus, oops, it looks like my absolute value. I need a little bit more room, sorry. So it's always minus the second one, though. Let's put the parenthesis. 5/2 times 1 squared minus 8 times 1, like that. And then, again, absolute value. So this, again, all should eventually be negative, but the absolute value will make it positive. Okay, and then we have plus. Now, I'm going to do this one also in black ink. The 6 will go in. So 5/2 times 6 squared minus 8 times 6. And then again, always minus the second one. Let's do that one in green also. Minus 5/2 times 1.6 squared minus 8 times 1.6. Okay, and I just have barely enough room. Okay, so that's that. All right, and then now, well, we just need to, I'm going to use a calculator to help me out with this arithmetic. With the arithmetic and the calculator, I'm going to use the Desmos graphing, or the scientific one, Math Tools Scientific. Okay, so I'm just going to plug those in. Let me scroll so we can see them both. Okay, so this in the black. All right, so I have 5 divided by 2 times 1.6 squared minus 8 times 1.6. Okay, so there's that portion. So we have negative 6.4 so far. Let me go ahead and give myself a little bit more room so we could write it. Okay, so let's write it and then we'll come back. So this is equal to, so absolute value, so that first one was negative 6.4. And then we have minus, and then we'll do the green one. Just setting it up with blanks for now. Okay, so here it is. And then here's what's nice about this. Again, it's the same thing. It's the same expression, except it's just 1 in there. So I'm going to copy and paste and change this into 1s. There we go. As long as I typed it right the first time, it's going to be right the second time, and it's negative 5.5 there. Okay, so let's get that, negative 5.5. And then let's go ahead and do these others. Plus, let's set up our parentheses. Okay, so I'm just setting up blanks, and then we'll fill it in. Okay, well, here's what, again, is nice about these problems. This in the green, we already did, right? The first time around, that was that one. It's right here. So I don't have to type it again. It's still negative 6.4. Okay, so let's put that in. So negative 6.4. And then one more, where now, again, I'm just going to copy and paste. So there it is. But I need to change it to just 6. So let's get rid of that. There it is. And then we'll press enter, and we see it's 42. Okay, and then now, well, one last thing. Let's simplify this inside of the absolute value. So negative 6.4 minus, so negative 6.4 minus parentheses, negative 5.5 parentheses. Okay, so be careful there. Okay, and we get negative 0.9. Okay, so that's the small amount of area that was below the axis. Okay, but the absolute values will make it positive. And then let's go ahead and combine this. So 42 minus a negative 6.4, that would be positive 48.4. And so the absolute value of negative 0.9, let's go ahead and we'll kind of go into this other problem a little bit. So this becomes positive 0.9 at this point, and then plus 48.4. And then now we could add it up together. Oops, let me rewrite that. So it looks like it's 49.3. Okay, so there we go. Okay, so regular area is a little bit more annoying because it takes a lot longer. Net area is just one integral and then power through that one integral. Okay, so notice that. So, and again, it's nice to know what happened. So this that I colored in red in the picture is negative, and we can see it's a negative number until I do the absolute value. So it looks like it's kind of correct here. And then the second one, again, it should be positive, all the blue, and we did get positive 48.4. So that's a good sign. Okay, so let's try one more. Just when we have more room anyway. Okay, so let's get that graph. So I'm going to go back to our Desmos calculator. So here's all the scratch work for the other one, but what I need now is just a whole different picture. Okay, so let's sketch that. So e to the 2x and then minus 10. Okay, so there's that picture right there, and it wants us to go from 0 to 2. Okay, so here's 0. Okay, so our picture, so let's go ahead and kind of copy it on the page. So we can see from 0, it is below the x-axis, and then at 2, let's see what it crosses at. So it crosses at 1.151, so that's a weird number. That's okay, so we'll still use it. It's an approximation. Okay, and then 1.151, and then 2 is kind of way up high, it looks like. Okay, anyway, so we'll just make a quick sketch and still use our sketch to show where it's below and above the x-axis. Okay, so our sketch is something like this. Okay, so that looks like the picture, but I'm exaggerating the scale to show, hey, this one's important to us. That was that 1.151. Like that. And so just like the last one, I'm going to shade in. So from 0 to 1.151 is below the x-axis, and then 2 somewhere eventually is 2, and that's above the x-axis. Okay, so it's 0 to 1.51, and then somewhere is a 2 eventually. Okay, so that means we need to break it into two integrals again. So our area is equal to, so this one also starts below the x-axis, so that one should be negative, but we will put it in absolute values to make sure it stays positive. Okay, and it begins at 0 as our x-coordinate, and it ends at x equals 1.151. And then we just put in the function e to the 2x minus 10. And then we just attach dx at the end for notation. Okay, but again, this in the red should be negative, so we put these big old absolute values on it to make sure it's going to stay positive. And then we'll add the blue one. So plus another integral. That one starts at 1.51, and it goes to 2, and then it's the same old function, e to the 2x minus 10 dx. Okay, and then now it's similar to before, where we just be careful with the math. Okay, so our area is equal to, so this one in the red, let's keep it in red, and I'm going to put the absolute values at the end. Okay, the integral of e to the 2x, well, that's our rule where we have a constant times our x in the power. So that just means copy it and paste it, and then divide by that constant there. So e to the 2x over 2, and then minus, well, we just need to attach an x to the 10. There we go. And then the bounds would be from 0 to 1.151, and then absolute values. And then we still have the plus. Well, it's the same antiderivative, so it's e to the 2x over 2 minus 10x, but the bounds are different, 1.151 to 2. Okay, and then now just keep going. We're going to plug those in. Okay, so I'm going to plug the 1.151 in black ink into the x's. So let's put it over here a little bit to make sure we're going to have enough room. So it's e to the 2 times 1.151 There we go. Minus 10 times 1.151. So there's that one. And then again, always minus. Let's do that one in green. Always minus the second one going in. Minus, if we plug 0 in, we would have e to the 0 over 2. And then minus 10 times 0, I guess just to show it. There we go. And then that's all in absolute values. And then plus everything in the blue. First, we'll plug in the 2. Let's do that in black also. So it'd be e to the 2 times 2 over 2 minus 10 times 2, all in parentheses. And then, like always, minus the second portion, minus e to the 2 times 1.151. There we go. Over 2 minus 10 times 1.151. Okay, so there's our giant setup. Okay, and then now it's just calculator work. Okay, so if you're comfortable with the calculator, you can kind of move on if you want, or fast forward and see if you got the same thing when you plug it in. Okay, so I'm going to scroll, and then I'm going to use my scientific one again. Okay, so the scientific one, I'm just going to type that in exactly as I see it. So I've got e to the 2 times, let's put that all in parentheses. There we go, 2 times 1.151, parentheses, move it over, divide by 2, and then minus 10 times 1.151, parentheses. Okay, so we get that number, the negative 6.513. So I'll do it to 3 decimals. Okay, so we have, let's scroll a little bit. Okay, so I'm going to just kind of plug them in. So negative 6.153 went in. And then minus, this one I'm going to do without a calculator. E to the 0 is 1. Divided by 2 would be 0.5. Minus 0 would stay 0.5. Okay, so that one I'm going to skip, but you could just plug it in as well. Okay, so we have the first one. Oops, I wrote it down wrong. 6.513, not 153. 513. There we go. Okay, and then plus this one. That one I'm going to do copy and paste to help me in our previous one here. So let's copy and paste. And then I just need to change the 1.151 into 2. There we go. And that one also 2. Okay, so to 3 decimals, it would be 7.299. So we have 7.299. And then minus this in the green. Well, this in the green matches this first one in this problem. So notice the same numbers. So it will be negative 6.513. Okay, and that's pretty common when you have multiple integrals with this find an area. Okay, so it's usually one of them or two of them are the same thing. Okay, and then now, well, I'm getting low on room, but let's go ahead and finish it off here. I think we could fit it. Okay, so I have the negative. Oops, let me just press enter. So I have the negative 6.513 minus 0.5 is the negative 7.013. Okay, so I'm going to put that negative 7.013 right there is that portion. And then these ones I'm going to just go ahead and add together as well. So it's 7.299 minus a negative, let's just say plus 6.513. And we get 13.812. Okay, so it's really just plus 13.182. Okay, and let me make sure I wrote that right. 13.812. I keep mixing those up, huh? Okay, so 13.812. Okay, and then this in the absolute values does become positive, so I'm just going to finish it off here. Let's add 13.812 plus the 7.013. And we get 20.825 rounded to 3 decimals. Okay, so this, I'm just going to put it 20.813 rounded to 3 decimals since I ran out of room. Let me make sure I wrote it down right. Well, what am I thinking? 20.825. I don't know what I'm seeing today. Okay, so let's write that 825. Okay, so that is the area. Okay, because again, the area considers both of these regions, the red and the blue, as positives. So we have to split it up because regular integrals counts the area below as negative. So we can't just do these in one big integral. It is always split up into 2. Okay, so take your time with it. Maybe give yourself more space than what I did here. All right, but I think it's good. So if you have any questions, please let me know. Otherwise, thanks for watching, and I'll see you next time.